Thank you for the introduction. I'm very excited to be here this afternoon. I love to talk about machine learning, and I appreciate that you all are taking an hour out of your busy schedule to listen to me. A quick word on my background. I'm actually Danish, but left Denmark 25 years ago. Most recently, been about a year at Uber, head of machine learning, which basically means that I run a team, a very large team that provide machine learning as a service across the company. There are three big areas. The first area is our prime business. It's riders and drivers and trips. A lot of machine learning to be done there. We'll talk about that soon. The second big area is map generation. We need maps that are far superior to any other maps for our vehicles. We need to guarantee that if you order a vehicle to your house, that it stops right in front of your driveway and not the neighbor's. We want you to be dropped off at the right bar or the right restaurant, not next to it, or not in the neighborhood of it. Yeah? The third big area is self-driving vehicles. That's also a big machine learning topic. My team is providing the platform support for all these areas. I'm going to talk a bit about some of it. I'm also gonna talk a bit about where I worked before Uber, where I ran the machine learning at Amazon. I ran the machine learning team that provided services for the rest of the company. I also launched machine learning as a public service in Amazon Web Services, AWS, so that Amazon's cloud customers could get access to the same technologies as were used inside the company. Before Amazon, I spent 9 years at Microsoft. I ran the machine learning and tools group. I had several thousand users inside Microsoft. Also did a number of things in the mobile space. Before Microsoft, IBM Research, actually in between Microsoft, IBM Research, I was in 2 startups doing speech-enabled virtual assistants similar to Siri. Was launched in the US under the OnStar brand from General Motors. So that was a bit about myself. The objective of my talk today is to give you a sort of deep sense or deep intuition of what machine learning is, how it works, and what it can potentially do for your business. I'm not going to tell you what it can do, but I hope to give you enough information so that you can sort of relate it to your particular business and get some ideas. My mission is, or my message is going to be that you have to seriously consider this, or you may be in trouble, or your business may be in trouble. But let's quickly look at my agenda for this next hour here. I'm going to talk a bit about Uber just to get the facts in place. I'm going to talk about a bit about supply chains, some of the challenges and trends I have seen at Uber and at Amazon. Then I'm going to talk about, give you an introduction to machine learning and artificial intelligence. I'm going to sort of go a bit under and give you some examples of how it works. It can be very difficult stuff, but I'm going to give you sort of an intuition of how it works. And I'm going to talk a bit at the end of my talk about dogfights and multi-armed bandits, whatever that is. But that's going to be really exciting, I can guarantee you. And then I'm going to conclude my talk in 50 minutes or so with a bit about all the cloud services out there and some recommendations on how you can get started, or your businesses can get started using machine learning and AI to do a better job. Let's start about Uber quickly. Uber's mission is to provide transportation as reliable as running water everywhere for everyone. This is one of these missions that it sounds so simple. It's a bit like Bill Gates had for Microsoft, which is a PC on every desk. At Amazon, it's like providing the best customer service on earth. Yeah? These mission statements are very, very simple to make, very, very hard to execute on. Okay? So when I travel the world, I was in Copenhagen yesterday, Stockholm today, I was in Pittsburgh Friday, I live in Seattle, I work in San Francisco, I have another team in Boulder, Colorado. Whenever I go there, I leave the airport and I order an Uber. I never rent a car. I order an Uber, I have an invited talk to give, I order an Uber because I expect it to be there within a few minutes and I will get there in time. Yeah? So I think of this as running water. Yeah? Behind the scenes, it's very complicated to make sure that this car is always available for me and anyone else who needs it wherever they need it. Yeah? We are currently, and this is post-China, this is post where we merged Uber China with Didi. We are, as Uber, operating on 6 continents, in more than 70 countries, 425 cities, and we have at this point, over 8,000 employees. So it's becoming a pretty big company. Yeah? It took us 5 years to complete 1 billion trips. And that was back in December 2015. Yep, so that's pretty recently. By June this year, we completed the 2nd billion. Yeah? So it took 5 years for the first billion, 6 months for the next. And you can imagine that the next billion is likely going to come, sometime very soon. We are already in September. Yeah? So the growth of the business is pretty incredible. We have over 5 million trips happening every day. We have over 50 million active repeat riders globally. And another fun fact is that our pool service, the one where you for lower fee share the car with a stranger. Yeah, so you ask for a pool ride. On the way to your destination, the driver will pick up another passenger and either drop you off or drop the other passenger off first. Yeah? That fulfills the mission of more people in fewer cars to have less congestion, less pollution, and more efficiency. We did a survey and found that 10% of millennials, they postpone their car purchase because they can get around the city with Uber. They don't need a car. It's unnecessary. We sign up over 100,000 drivers at this moment a month, and we have well over 1.5 million drivers driving on the Uber platform worldwide. So that's some pretty big numbers. Operating a business of that growth and that size needs a lot of technology. I'm not really going to talk a lot about this, but we announced recently that we have self-driving cars. If you go to Pittsburgh, you will see them driving the streets of Pittsburgh, and very soon they will not be Ford Fusions, as I'm looking at here. They will actually be Volvos. So that's very exciting. Let me relate a bit to what I would call supply chain challenges, which I've seen from the inside at Amazon and now at Uber, which is a constant drive towards lower prices, faster delivery, and extremely high customer service expectations. Yeah? So this is why people are using Uber. This is why people are using Amazon. Yeah? They can get a product they know at this moment in time at the lowest possible price, and they get it immediately, more or less immediately. At Amazon, we are down to, in my area where I live, we are down to 60 minutes delivery. Yeah, so you can order something, and within the hour, it shows up. Yeah, by default, I would say half of the products I can order at Amazon, they have next day delivery, so it'll be there next morning. Yeah, so, and I know that the prices are going to be about the lowest possible I can find anywhere. Yeah. At the same time, we have demand volatility, which is really hard to deal with. Sometimes people order a lot, sometimes they don't order. We also have an extreme high number of products. I'm going to get more into this in the Amazon case, which is very interesting. And we also have extreme supply complexities. A lot of these products are not being made near the purchaser, but comes from foreign countries and needs to be transported and assembled and so on. So that's a lot of complexity right there. I want to add on the supply complexities. I don't know if you have heard about the Uber Eats service. It's very popular in the US. It's basically lunch ordered from an Uber Eats app. It's extremely popular. We are in many cities now in the US. I think we launched in London too. And I think we're going to come to other European cities soon. But it's basically ordering a lunch from one of your favorite restaurants from your phone, and it will show up within 30 minutes at your doorstep or at your office. It's very, very popular. But think about it for a moment there. There we have an Uber driver, we have an Uber customer, and we also have an independent restaurant delivering the product, and everything is on demand. Just imagine the complexities in making sure that every customer gets the burger they ordered on time and at a quality they expected. There's a lot of actors in there, very complicated stuff. More frequent shipments and transparency and sustainability. It's all this about people ordering all the time, they order multiple times a day, and then they also want to know a bit about how hard is this on the environment. They want to make sure that they understand the CO2 footprint of their actions, and all this is now baked into what I call the supply chain challenges. This is an Amazon fulfillment center. Just unbelievable, huge, and there's so much stuff in there and so much going on. It's mind-blowing. There are hundreds of them worldwide, and there's robots in there. It's generally very secretive what's going on in there. But it brings me into sort of the scale of Amazon as an example, with about, I don't know the exact number, and if I knew it, I wouldn't say it, but let's just say that publicly available numbers are around, 500 million products in the Amazon catalog. So they have 500 million SKUs. Think about it. They add up to 500,000 new products every day. Yeah. I remember being concerned at Amazon about the translation of product description between different languages, yeah? Because you have French and German, of course you have English, Italian, Spanish, and you have 500 million new products every day. You can even have people translating. That's why Amazon actually acquired a company, a startup, doing automatic translation services, yeah? Using machine learning, yeah? This is an interesting problem here, and I want to think about the talk from Absolute earlier today with the many different vodkas. There's this very long tail of demand. Yeah? When Amazon has 500 million products in their catalog, that's actually more products than customers. Yeah? So you can imagine how long the tail is. They have 900,000 products in their grocery store, baby store 1.2 million, beauty products 1.7, office products 6.7, sports products 24 million, clothing, 30 million, kitchen and home, 60 million, and the electronics part of Amazon is about 96 million products. And you know, what do they have? About 300 million customers, yeah? So you can imagine that the head is small and the tail is very, very long. How do you manage all that? Yeah? That's the challenge. Traditionally, that has been managed by people, but you cannot manage 500 million products and 300 million customers, or 1.5 million Uber drivers and 50 million Uber riders. You can't manage that by having people sitting and guessing and have, you know, certain ideas about how to do things. You need to put the machines in action for that. So that brings us to machine learning and AI. Machine learning is very hot right now. It is the hottest topic in the space of computer science and computer engineering. We see basically Amazon being run on machine learning, Uber increasingly being run on machine learning. But I think it's important to understand that that while the future, definitely in future in business, is going to be AI-based, it's very important to understand that it has been around for quite some time. Okay, so the Pandora music service, I should probably have used Spotify here, but now I use Pandora, started out as the music genome project for some students, I think 15 years ago, using machine learning to understand that if you like this music, you may also like this other music. Yeah, it's like 15 years ago or so. Yeah, but that's the core of Pandora, is this kind of understanding what music you like and play music for you that you haven't really heard about before. Yeah, but that you are likely to appreciate. Amazon Echo with the Alexa service, it's a voice-enabled assistant that can tell you how the weather is going to be, find radio channels, play music based on speech recognition, has been in the works for quite some time. Lots of machine learning in there. Netflix, you all know Netflix, I hope. When you open up Netflix, you get this recommendation of movies, different genres. All that is deep machine learning. Yeah, it's all run by PhDs. There's nobody sitting and deciding by hand what you're supposed to see and not see. It's all math. Yeah. Nest is a good example of it's a thermostat company. Thermostats are a pain to program, just like the old VCRs. Nobody can figure it out. Nest got this idea that mount me, connect me to your Wi-Fi, and you can control me from your phone, and you should really just tell me when it's too warm, too cold. Keep doing that for a couple of weeks, and I will start figuring out, listening to the Wi-Fi when you're home and not home, and figure out what temperature you like. And I can also get all the information about how cold it is outside, how cold it is going to be soon, or how warm it's going to be. And then the Nest thermostat just regulates itself, learning from the feedback from you. It's machine learning. Xbox One is another example. Kids playing Xbox Live. They play against other kids, or maybe adults. Matching these up is machine learning, because we don't really know what makes a good group of players play together. So what we've done is that we have basically looked at people playing and people playing long time together, and learn from those characteristics, and basically matching people up online so that they have a long-lasting, happy endeavor in front of the game box. Yeah? Again, it's machine learning. The systems learn how to do this. And Amazon, I already talked about it. Amazon is using machine learning everywhere, predicting your gender if you don't want to tell them, predicting your shoe size and making recommendations of what shoe size you should use or purchase, all the way through the system. All your emails that you receive, all the things you see on the page, everything is based on systems learning what you want to click on, because that's what matters. Yeah. A brief history, just to give you a perspective, is not as much history as it is a change in behavior. We started out many years ago in 1949. Claude Shannon, he wrote a chess-playing algorithm. It's basically a famous algorithm. It's called Minimax algorithm, but it's really efficient at playing games such as chess. So, very specific algorithm, solves one purpose: game playing. In '97, when I was at IBM, IBM built a custom piece of hardware called Deep Blue with custom software, including the Minimax algorithms and other things in there to beat the world champion in chess. Yeah? Very dedicated system. Okay? None of these systems are machine learning, they're algorithms. Yeah? Someone really thought about this, and they implemented something in a computer so that it could beat the world champion in chess. Yeah? We have IBM Watson that wins Jeopardy in 2011. It gave IBM such a marketing splash that the IBM AI product is now called Watson. But in fact, it was really curated data and a very specific Q&A algorithm that basically very quickly, at the speed of a computer, were able to interpret the question and find the right pre-curated answer to that question. Yeah? It's not AI and it's not machine learning. Not really. Yeah? However, recently there has a big change happening. Earlier this year, AlphaGo, the AlphaGo system from Google, beat the world champion in Go playing, using a generic machine learning algorithm called deep learning, and using graphical processing units from NVIDIA, all fairly standard software in a very high scalable configuration. And they used a machine learning technology that can do many, many other things. But in this case, they trained it to play Go. Yeah? It's really a technology that's been mostly used in computer vision. They have other examples of this same system playing against Atari, just looking at the screen and firing rockets and win, just by using computer vision. Yeah? In this case, you can see how Go is it's a black and white pixel game in a sense, and there's some vision to it. But deep inside, the system developed a strategy to beat the world champion. This happened 5 to 10 years ahead of schedule. Yeah? This was not predicted. Yeah? So when everybody tells you a computer can only do what it's told to do, that's not true, no longer. So AlphaGo is an example of a computer that played millions and millions of games against itself and became the world champion. Yeah? Nobody told it the rules of Go. There are no rules implemented in that system. It just taught itself by playing millions and millions, and many millions of games. Yeah? Initially, it was probably really bad at it. Yeah? So we see this incredible shift from clever algorithms and custom hardware software, rule-based systems, into machine learning. So when we think about the rule-based systems, this is really using an all-knowing programmer, writing a program, reads data in, produce a result, have some feedback. The feedback is really, bugs and customer complaints and things like that. So we go in and fix the code, yeah? And the code just grows and grows and grows and gets more complicated, yeah? But it's based on this idea that Newton had, that everything past, present, and future can be computed deterministically. And we now know that is not the case, yeah? There's nothing that works that way, yeah? So this is a dying concept. It works well for a transactional database and a banking system, sure, but for complex, very large systems, that will not work. Instead, We take a learning algorithm. It's actually, in most cases, a very simple, very generic learning algorithm. And we feed historic data through it. Say we're a shipping company, we feed millions of shipping records from the past through this learning algorithm with weight and dimensions and addresses and times of day and year, et cetera, and shipping times. Yeah? We feed it through the system. It builds a model based on all this historic data. And now I take a brand new shipping record. I haven't shipped the product yet. Feed it in the model, and it makes a prediction and says, you know, it's going to be a 5-day shipping based on what I learned. Yeah. So in this world, I base my decision making on, you can say, a black box, a system that was trained on large amounts of data and now makes predictions for me. And I use those predictions to do something about it. Yeah. I don't get an exact result with this system based on historic data. The likely shipping time is 5 days, maybe 4 days, maybe 6 days, but more likely 5 days. Yeah. The whole concept borrows from, this is actually a picture of Heisenberg in their quantum mechanics. It is really based on everything that we do and see around us is based on these distributions. There are likelihoods for shipping. There's a likelihood, the big likelihood or great likelihood that it's going to come out in 5 days, but it may be sooner, it may be a little later. Nothing is exact. Yeah? And that is really how machine learning works. It's all about probabilities and understanding those probabilities. Yeah? Let me quickly sort of just dive in to an example. My numbers are missing here. Oops. Okay. Okay, let me explain this table that is empty. What I put in there is some housing data. So it's basically the ground truth out there is how much is a house sold for, a property, and there's some. Let's go to down here. There's some square footage, number of bedrooms, the age of the house, and the ratings of the schools in the where the house is. Yeah. And what you can do is you can basically look at this table and say 4 bedrooms, 1,000 square feet, etc. And it was $100,000. And this other one, it's a larger home, and it was sold for $200,000, etc. Yeah. So we take these data, these facts in with these ground truth, and what the machine learning system will try to do is to create a function. And you can see that function down there. It may be a little hard to see, but let me do the next one here. It's easier to read on this one. Basically, I have some input. I have square footage, bedrooms, age, and school rating. Yeah, each of them carries some kind of weight. Yeah, the W 1, 2, 3, 4, some kind of weight. Yeah, and all that adds up to a price. Yeah, and the way the machine learning system works is that it will take in thousands or millions of records of square footage, bedrooms, age, school rating, and price, actually sold price, yeah? And it will keep iterating over those key facts and try to guess the value of W 1, 2, 3, and 4, the weights, yeah? And try to literally use random numbers and try to keep going over and over and over and over until these weights stabilize, converge. When I have that, when it has converged for me, I can now take a home that's up for sale. Yeah, I can basically say that's the square footage, number of bedrooms, the age of the house, and the school rating, and it will use those 4 weights and add it up to a guess, a prediction, what the house may be going for at the end of the day. Yeah? Yeah? It's not exact science. Yeah? The house may be sold for more or for less, but most likely it's going to be pretty close. And it's really a naive iterative algorithm that just takes millions of records in Yeah? And how can you improve this? You can add more input. Maybe we add something about, was the kitchen renovated recently? How many bathrooms? What's the size of the garden? And you just keep adding. Typically in these cases, there are maybe 200, 300, 400 of those inputs. Yeah? So there are 200, 300, 400 of those W's that needs to be decided by the computer. Okay? So why is machine learning becoming so popular? One of the reasons is that now we have cloud computing, we have fast computers, and we have lots of data. So we can actually compute these W's in there. But they're hard to compute when you have 400, 500, when you have 1,000, or many, many thousands of them. Yeah? But the more you have, you tend to get a better result. Yeah? There are different kinds of learning algorithms. Regression is one of them. It basically, that was the house pricing thing. It gives you a number. Yeah? So it predicts some number and then some distribution that may be, around that number. Yeah? Another one is classification. You know this from email, spam or not spam. Yeah? Real email or spam. It's classification. Binary classification. Machine learning is awesome at that. Ranking. Every time you use Google, whenever you do a query on Google, they actually pull out 1,000 results and they rank them, and you see the 10 best ones. Yeah? That's a ranking algorithm. It's based on a lot of things, really a lot of things, but one of them is in particular what you actually click on. That will boost the rank of that link for the next person who write that same query. Yeah? So ranking is a very important machine learning thing too. Yeah? A lot of machine learning is fact-based, so it's supervised. Yeah? I gave you an example of homes sold and their prices. Yeah? So I have the facts. The facts in history allows me to make predictions about the future. There's also what's called unsupervised learning. It's harder, but more powerful in the sense that I don't have to involve people in it. The computer will look at the data and try to make sense of it without having people doing that. So clustering, as I show in this small example here, is an example of that. Things that belong together, computers can see that. Yeah? And finally, some of the most interesting developments going on is in reinforcement learning. We call that good dog, bad dog. So basically the machine learning system is given a reward every time it's guessing right, and every time it's guessing wrong, it's being punished. And of course the machine learning system wants to be, a good dog. So that was how AlphaGo learned to play Go. Yeah? It tried to win the game, and every time it made a move that made it eventually lose the game, that move was now tagged as like probably not a good move. Yeah? And this is how dogs, they learn. Yeah? They try to please us, and they do something, and they think we'll be happy, but we do not, and they remember that, don't do that again. Yeah? So they tend to only do the good things. That's an example of machine learning. Yeah? I want to talk specifically, because it's hot, about neural networks inspired by how the brain works. I showed you before how this input can be mapped to an output, yeah? But that was sort of a very simple model, and that's the most popular machine learning model, by the way, yeah? I have these weights, I add it all up, and I get a value. That's 80% of all machine learning today, and that's good, yeah? However, in cases where there are more complicated relationships that are not sort of linear, that it's not all adding up, some is adding up and some is like not, it's going the other way, it's like a negative, yeah? That is a little harder to model, but one example of a technique that can do that is neural networks. It's really, imagine the inputs now, and you remember we had these weights, but now there's like a weight on each arrow, and it maps into something that we call hidden, which we really don't know what that is, but eventually that maps to the output, which is the price. Such systems tend to produce better results when there are more complicated relationships in place, when it's not just simply adding things up with different weights and getting a number. So these systems are used a lot when we're working on things where we don't know the actual relationship between the inputs. Yeah. In 2012, machine learning went through a whole revolution called deep learning, and this is the neural networks on steroids. So basically what some researchers got this idea a while back, but then the computers sort of caught up with the idea in 2012. And we created what we call deep neural networks, where we basically add layers and layers of this until we get the output. These kind of networks are very, very capable because they can model big complexities. And this is where there is a huge promise that machine learning can actually become what people think more of as AI, where systems can do more complex reasoning. Yeah? But again, it's really a simple model of some inputs that flows through a system and result in an output. Yeah? When we look at these deep neural networks, and they can be like 100 layers deep, they start becoming really interesting. The first breakthrough was in vision, computer vision, where you basically train these networks to on a large number of images. Yeah, and think of this as model of a biological brain. Yeah, when you show an image of something, what was found was that certain nodes would light up when they saw when the system saw certain things. Yeah. So in this example here, if you show a picture of a human face, one node in the middle of this mesh, one node would light up, which was an indication that was a human face. If you show a cat instead, another node lights up. Yeah. So this is sort of getting almost a little spooky, because we can't explain how it works because it's so complex. The largest system we have built of this nature today is about 200 billion arrows, so the edges in there, yeah, 200 billion. That's as far as I know the largest deep neural networks today that we are capable of building. In comparison to a human brain, those arrows, they correspond to the synapses in the brain. A human brain has about a quadrillion synapses. So that's 1,000 trillion, yeah? So I said we have 200 billion here, 5 times more, that's a trillion. When we are at a trillion, we only need 1,000 times more. Then we are at the level of what a human brain has, yeah? The nodes, the human brain has about 100 billion of the nodes, yeah? Elephants have actually 3 times as many. The elephant brain is 3 times bigger, but clearly not as intelligent as us, yeah? So it's not all in the numbers, yeah? But at least we are within reach number-wise, but there's probably more to the story than that, yeah? So now I told you about machine learning, I told you about training these systems, and they can now make predictions for us. We can be a mortgage company. We feed in, 300-400 inputs, and out is a binary classification saying, give the person a mortgage loan or don't, because they're going to go bankrupt. Yeah, that's how these things are used. Yeah. The important thing is actually now, with this piece of information, we need to make decisions, and that's another important point I want to make is that those decisions needs to be automated too. Yeah. In this, we talk a bit about dogfights and multi-armed bandits. So dogfights are fighter planes trying to shoot each other down, and multi-armed bandits, that's the slot machines in the casino. Yeah. Let's first talk about the dogfights. Yeah. It was a U.S. Air Force pilot who, by observing dogfights in the Korean War, noticed that the the faster you could sort of turn your plane, the more likely you were to win the dogfight. It was not about the guns, it was not about, armor and all these other things, it was just about agility, yeah? And that's why he actually is called the father of the F-16 fighter plane, because the F-16 fighter plane is a very fragile, single engine, I think, plane. It's very lightweight. At the time, actually, the US Air Force really wanted bigger and heavier fighter planes, yeah? And he did some work and formalized it and introduced the OODA Loop, yeah? Which is basically that you observe, you orient yourself, think of this as a pilot, yeah? You look at the situation, you figure out where you are, and then you make a decision, and then you act upon that decision. And what he found with the pilots were, the faster you run this loop, even if you make mistakes, you're gonna win, yeah? And my excitement, this is not traditional machine learning stuff, yeah? This is like business talk, yeah? But my excitement was when I read on the papers he wrote. He had, for instance, in there, he argued that a mathematician, Gödel, has an incompleteness theorem that I know about, and it's very relevant for machine learning. And John Boyd here, he basically said that, well, any model of reality is incomplete and must continuously be refined, yeah? So anything we sort of in our business work on, we know that we're always missing something, yeah? The other thing he observed was Heisenberg, and that's what I sort of independently observed myself, which is like a lot of the ideas for quantum mechanics, influence computer science and machine learning. And he had observed that too in pilots and in business, which is basically that you can observe yourself to death if you try to really understand every freaking detail, yeah? But you can't really understand it. The deeper you look, the more confusing it gets, yeah? And then the last thing is Boltzmann, which is that any system you're trying to maintain order of is constantly trying to break down for you, yeah? This is entropy, and this happens in information science too, yeah? So with those things together, we are looking at this, and this is actually bias for action. This is one of Jeff Bezos from Amazon. That's one of his key things, is like, you have to take action. Even if you are not quite sure what you need to do it anyway, because you will learn from it, and the faster you run in this loop, the better, yeah? So remember the OODA loop here, it's super important, yeah? And how does this relate to machine learning? Well, let's hold on for 2 seconds and let's talk about multi-armed bandits, slot machines in a casino. I don't know if you've been to Las Vegas. I've been there once. It's not really something I like, but I looked at the slot machines. And they have slot machines in the hallways, and they have slot machines sort of in the middle of, deep inside these big halls. And what I have found out from Wikipedia and Google is that slot machines, they have different, you have different winnings, yeah? So what they do is that they put the ones in the hallways, you win less, but you win more often, because that sort of makes you feel like happy and optimistic, and then you enter the big hall with the bigger bets, and there you win much, much less frequently, yeah? So this leaves us with some very interesting problems. If you think about machine learning giving you some predictions that you can act upon. The OODA loop, which is, well, I have these predictions, let me act upon them in my business. And then, with the multi-armed bandit approach, which is also something that is implemented as algorithms in computers, there are strict mathematical methods to optimize my winnings. Yeah? It's really a concept of exploration versus exploitation. So you walk up to the first slot machine and you play it a bit and you get some winnings. That's called exploitation, yeah? You're pretty happy, you're winning, but there's all these other slot machines over there, and there may be greater winnings from those, but you don't know. You can go over there and play, that's exploration, but now you're not necessarily exploiting any longer because they may actually have a lower percentage outcome for you, but you don't know, yeah? So what you have to do is you have to balance exploitation versus exploration, yeah? And think back to the OODA loop and to the predictions made with machine learning, yeah? So you try to operate your business based on these predictions, and now you actually need to, for instance, a customer is about to leave you. The prediction has been made that a customer is about to leave you, yeah? Actually, you have millions of customers, so thousands are always about to leave your service or leave your company as customers, yeah? So what you do, that's what machine learning tells you. Yeah? It can predict people, it predict customer churn. Yeah? In the OODA loop, you now know that, and you need to take action on it. Yeah, and with multi-arm bandits, what it allows you to do is a formalized framework, and the algorithms for this allows you to take multiple different kinds of actions. Yeah, and basically work with exploration versus exploitation in attempts to keep those customers. Yeah. Companies are doing that all the time, but most often this is a single business person somewhere deciding that all customers that the machine learning system predicts are going to leave my service next month, send them a voucher for $10 or send them a free month or whatever, and I hope they will stay. Yeah. But in fact, just like the world champion in Go was beaten by a computer, that business person is also going to be beaten by the system, yeah, because that person is not going to know what all these different consumers are going to want to stay with the service, yeah. So think about playing the multi-arm bandit. It has a cost. You put a coin in every time, yeah. You provide customers with incentives, that's the coins, yeah. You also have an adversarial environment, yeah. Imagine the slot machines, while you're trying to figure out which ones to play, the owner is running around on the back and reprogramming them all the time, yeah. Yeah. So this sort of brings it all together that you do make your predictions using machine learning, then you have to have a way to have your business responding to those predictions. And in that context, you also have to run a lot of what we call basically experiments on your customers to figure out what it takes, in this case, for instance, to keep the customer on board. Yeah? So one company who's really, really awesome at this, who perfected this, is Google. Yeah? They do that on the ads that I show out there. Yeah? If you type in the keyword voice over IP, they list all these. The way these ads are ordered in there is not, the first ad showing up is not the ad that plays the highest fee to Google. They didn't win the auction necessarily. Yeah? The ad that shows up on top is the ad that, at the fee that the advertiser will pay, and the likelihood that you, Google, will click on it, they maximize for their revenue. So that rank out there is a multi-armed bandit experiment there, and they are constantly refining it to make sure that they increase the revenue to the absolute theoretical maximum possible. Yeah, that's how they run their business, and that's why they make billions and billions of dollars. And many other businesses don't have that level of refinement. Another company that got this really, really well is Facebook and their sponsored posts. That's why Facebook stock is going up, because they really figured out how to put posts into your newsfeed between your friends posting. There are posts in there, they look so awful relevant to you that you click on them thinking maybe a friend posted this. But they didn't, it was an advertiser. Yeah? This is based on these concepts, and they are really changing business. I want to go back to my machine learning diagram here. I'm running out of time. You remember this about historic data, creating a model, can make predictions for me. And what I really want to emphasize here is that based on those predictions, you make experiments and you take a feedback loop in there, in that system, and refine your models based on those experiments. And that is really how things should be done. Let me run through, I'm gonna try to skip this slide here because it's just some details that is not too important for you. Let's see. At Uber, we have developed a platform so that all parts of the company can use machine learning without being machine learning scientists, specialists, and have PhDs. But really, just like a software engineer wants to use a database and use MySQL, in Uber and at Amazon, that software engineer can use machine learning as one component out of many, many other components being used to build a smartphone app or a smart website. Yeah? So we use all open source technologies that basically allow us to suck in a lot of standardized Uber data so that every team, whether it's a food delivery service or the normal Uber X or it's Uber Pool, they have this as one thing they can use to make their service smarter. I also want to emphasize, here we go, that with all the cloud services out there, a lot of businesses can jump into this. They should pick low-hanging fruit. They should pick business problems that are very obvious. When I was at Amazon, I had one customer for the Amazon Web Services. One customer was a cable TV company in the US, and they did not have any customer churn analysis. Yeah? So they didn't know anything about customers who were about to quit. So obviously they didn't do anything about it. Yeah? That's like, you have millions of customers who quit in the past. Run them through the system and learn from it and identify your current customers at risk. Yeah? It's so easy. Yeah? So easy. Start with supervised data. That's supervised data, yeah? I know from my past, I had 1 million customers quitting my service. I know they quit. Yeah? So I have all the inputs and they quit. Yeah? So let me identify current customers with the same inputs. They're likely to quit too. That's supervised. Don't use big data. Big data is like petabytes. Don't go there. You don't have to go there. Big data is not 1 million records. Yeah. 1 million records is easy to work with, and 1 million records, fine. You can learn from 1 million records easily. Yeah. And then use cloud-based offerings. I wrote this one, so you should use Amazon. I also did this one before I joined Amazon. You can play with that too. Google has something. There's a company called BigML. I like what they have. They have a lot of visualizations that makes it easier to understand what's going on. But these are all cloud services that a software engineer, not a PhD, not a data scientist, not a machine learning scientist, but a software engineer can start using this and basically make your business smarter. That was about it.
Wow, Danny, thank you for really taking us in deep in machine learning. I mean,
Yeah.
I was like flabbergasted
Okay,
at
I hope it was not too deep.
all the opportunities. I'm just thinking, how far can we reach with machine learning, and to the point that it nearly becomes overpowering to us as humans, and also how far out in industries? I'm thinking war, conflict, and so forth.
Yeah. So I like to think about machine learning sort of in a perspective of, as humans, and myself included, we have this tendency to completely and totally overestimate what we're going to do the next 18 months, or even 6 months, yeah? Or next Wednesday, I'm going to do this, this, and that. I'm going to change the world, yeah? Next year, nothing is going to be, yeah? When next year comes, we're going to be like, yeah, I made some progress with machine learning, but, I'm not really changing the world, yeah? At the same time, we completely underestimate what can happen in a decade, yeah? So I think that right now, we are going through some significant improvements and some almost revolutions with machine learning, but it's not really big yet. But
No,
10
not
years
yet.
from now,
Yeah, exactly.
when you put these things together, I often think about it as when you take machine learning to improve customer churn, so now you hold on to the customer better, yeah? And you use machine learning to make the much better recommendations to the customer so they are more happy when they use your service. When you do that in 100 places, you now become a much more intelligent business. And the customer think that you are fantastic. And people think, I really think so, Amazon is fantastic, yeah? But they also use machine learning like in every aspect in making sure that things are produced in time so that when you order them, they actually exist. And they're shipped on time, and they arrive on time, and they know if they don't arrive on time, they figure out why. And all that is really automated. It's not people sitting there trying to figure it out. Yeah?
And just something more substantial to Uber. I mean, in the next, because evolution and innovation go so quickly nowadays,
Yeah.
but let's say a few years' time, how will machine learning, what kind of impact will it have on Uber? I know already, you're sitting
Yeah.
with a consortium of competitors looking at how to...
Yeah. So machine learning will make our basic service better by the day. We'll be much better at making sure that drivers are, or the vehicles are, not 4 minutes, but 3 minutes or 2 minutes away, because we can predict the likelihood of you ordering a car at any time in the future. We can also give you much better recommendations of what to do if you want to go somewhere. We can say, have you thought about some other place? Other people like you, they often go there too. Stuff like that, inch by inch improving it. But I think when you look further out, that's when you look at self-driving cars, you look at other services like our lunch service being brought to, that is going to change the way that people live.
And it's also, I mean, Uber becomes, a technology hub like nearly no one else with all this machine learning. What kind of collaborations, because collaboration has been a word that's been arisen quite a lot here, do you have in the pipeline? It's not just about Uber anymore.
Yeah, I think a lot of the... now we're located in Silicon Valley, and it's very interesting that a lot of the things we do at the very technical level is sharing a lot of software and open source. At Uber, we use software that has been developed by Airbnb. We often, on a monthly basis, meet with people from Google, from Netflix, from Twitter.
Exactly.
Twitter is just down the street from where we are. Airbnb is across the street. There's a lot of excitement going on and sharing information, which is pretty dramatic.
Anybody in the audience have any questions? No one in the audience.
Okay.
Yeah, you have a question? Perfect. Do you have...
When you mentioned predictions, I'm thinking from a transportation point of view and taxis and stuff. When I'm imagining you're going to get to the point where you start inputting kind of events so that you know when things end. Because I think we've all probably been to the point where we get out of a concert and there are no taxis.
Yeah.
So that kind of prediction, is that also part of what you work with?
That's a very good point. By basically consuming event streams, so you know that when a football game or a sports event is coming up, when it's over, with all that information, you can start mobilizing the drivers. I know that is happening at the city level today, where people basically, with feet on the ground, they know what's going on, and they will call drivers, or they will send emails or text messages out saying, be ready to pick up people after this concert. but a lot of that is clearly going to be automated in the future.
So there'll be a line of Ubers waiting outside when
Oh,
we
yeah.
finish. That's walking the talk instantaneously. Yes.
When will you be able to forecast, protect the world economy?
Sorry, the verdict,
The economy.
the economy.
Yeah.
It's a good one. It's a
must be
Steve Jobs moment.
This is interesting. It's interesting. When we try to hire machine learning scientists today, they do not. I do get a lot coming to me and to Amazon and Microsoft and Google and so on, but a very, very, very large part of them goes to the financial industry, especially hedge funds. And hedge funds are known as sucking up every machine learning person they can come by, because it is a technology where they are able to take a lot of inputs in. There's a dramatic change in the whole financial industry and for hedge funds, where they're switching, in these years, they are switching from high-frequency trading to medium and low-frequency trading. They're switching from highly mathematical, deterministic methods of making trades within, fractions of a millisecond, to holding on to stock for minutes and hours and days, based on 10 to 50,000 information sources, using deep neural networks to kind of get an essence out of, is this stock gonna go up or gonna go down? And that's a big change happening these years. Some of the most successful growing hedge funds are using these technologies and switching away from the more mechanical nanosecond-based trading.
Interesting. So much happening. Soon we humans don't need to think, we don't need to do anything. We have artificial intelligence,
just
machine learning, we have Google, just to Google everything. But hopefully we'll have some kind of position in the world anyway. But thank you so much
you.
for that interesting
Thank you.
talk. Thank you.